times we need to create precise and accurate figures. Construction helps in creating these precise and accurate figures. Here in this section, we are going to learn about some basic construction. Construction is used in various fields. For example, in the field of engineering, modeling, designing, architectural drawings. As for real-world applications, most of the buildings around you older than 30 years were designed by an architect that manually used geometric constructions for their drawings. Even a tailor must have a knowledge about this for taking the measurements of the cloth. Let's see what are the tools required. We need a protractor, a compass and a graduated scale. In this section, we have to deal with some basic constructions. We need to construct angle bisector, perpendicular bisector, a 60-degree angle. Let's discuss the angle bisector and then we will see its construction. What is an angle bisector? A line that splits an angle into two equal angles is called the angle bisector. We will see one example. Here, the angle bisector splits a 90-degree into two equal angles. That is, each angle will be now 45-degree. Now, let's see the construction. Construction statement. To construct the bisector of a given angle. Given an angle ABC, we want to construct its bisector. Now, let's see the steps of construction. Step 1. Taking B as center, draw an arc of any radius intersecting BA and BC at points E and D respectively. Now, second, taking D and E as centers and with a radius more than half of D, draw arcs to intersect each other. Now, mark the point as F. Join BF. So, BF is the required bisector of the angle ABC. Along with this, you need to give the justification. So, to prove BF bisects angle ABC, that is angle EBF is equal to angle DBF, join DF and EF. Refer the figure. Now, consider the triangle BEF and triangle BDF. BE equal to BD, what is the reason? Radii of the same arc. EF is equal to DF, reason? Arcs of equal radii. BF is equal to BF because it is a common side. Therefore, we can say by SSS rule that triangle BEF is congruent to triangle BDF. Also by CPCT, we can say angle EBF is equal to angle DBF. Thus, BF is the angle bisector of angle ABC, hence justified. Next, we will see what is a perpendicular bisector and then we will move on to its construction. Perpendicular bisector. It is a line segment which intersects another line perpendicularly and divides it into two equal parts. Two lines are said to be perpendicular to each other when they intersect in such a way that they form 90 degrees with each other. In the figure, you can see that AB is a given line segment and PQ is a perpendicular bisector of AB. So, if the question comes to construct a perpendicular bisector, our aim is to draw the line PQ using compass and ruler. And once drawn, you can verify that the angle they formed is 90 degree using the protractor, right? Now, let's move on to the construction part. Construction 2. The statement is to construct the perpendicular bisector of a given line segment. So, what is a given? A line segment is given AB and we want to construct this perpendicular bisector. Let's move on to the steps of construction. Step number 1. Taking A and B as centers and with a radius more than half of AB, draw arcs on the top and bottom of AB to intersect each other. Second step, let the point where arcs intersect on top of AB be P and the point where arcs intersect at the bottom be Q. Now join PQ. Let PQ intersect AB at the point M. Thus, line PMQ is the required perpendicular bisector of AB. Let's move on to the justification. To prove PQ is a perpendicular bisector, that is AM is equal to BM. Also, angle PMA is equal to angle PMB equal 90 degree. We need to check that also, right? Now, join A and B to both P and Q to form AP, AQ, BP and BQ. Refer the figure. Now, consider triangle PAQ and triangle PBQ in the figure. You can see AP equal to BP, reason arcs of equal radii. AQ is equal to BQ, reason arcs of equal radii. PQ is equal to PQ because it's a common side. So, we can say by SSS rule that triangle PAQ is congruent to triangle PBQ. Also by CPCT, we can say angle APM is equal to angle BPM. Mark it as equation number 1. Now, in triangle PAM and triangle PBM, AP is equal to BP, reason arcs of equal radii. Now, PM is equal to PM, it's a common side. Angle APM is equal to angle BPM, already from equation 1. So, we can say by SAS rule that triangle PAM is congruent to triangle PBM. Also, AM is equal to BM by CPCT. Also, angle PMA will be equal to angle PMB by CPCT. Mark it as equation number 2. Now, angle PMA plus angle PMB equal to 180 degree. Therefore, the linear pair axiom. Again, angle PMA plus angle PMA equal to 180 degree from equation number 2. 2 angle PMA is equal to 180 degree, or angle PMA is equal to 180 degree by 2, which is equal to 90 degree. Therefore, angle PMB is equal to angle PMA is equal to 90 degree. Thus, we have proved AM is equal to BM as well as angle PMA is equal to angle PMB is equal to 90 degree. Therefore, we can say PQ is the perpendicular bisector of AB, hence justified. Next, we will see the construction of 60 degree. That is construction 3 statement to construct an angle of 60 degree at the initial point of a given ray. Steps of construction. First one, draw a ray AB with the initial point A. Now, taking A as center and with some radius, draw an arc which intersects AB at point D. Next step, taking D as center and with the same radius as before, draw an arc intersecting the previously drawn arc at point E. Next step, draw the ray AC passing through E. Thus, you can see angle CAB is equal to 60 degree, which is the required angle for us. Let's move on to the justification part. We need to prove angle CAB is equal to 60 degree. So, for that, join DE. Now, since RKD is equal to RKE and using the same radius, we drew RTE. Thus, their radius will be the same. Therefore, AE is equal to AD is equal to DE. Reason, radius of equal arcs by construction, right? Therefore, triangle EAD is now an equilateral triangle, and we know angle EAD is equal to 60 degree. Reason, all angles of equilateral triangle are 60 degree, which implies angle CAB is equal to 60 degree, hence justified. Now, let's have a recap of what we have learned in this section. We were dealing with some basic constructions. That is, one, we have considered to construct the bisector of a given angle. Then we have seen the construction of perpendicular bisector of a given line segment. And the third construction, we have seen the construct an angle of 60 degree at the initial point of a given ray.